Have you ever thought about this? How you can travel for miles, be completely exhausted, but in the world of physics, you might not have gone anywhere at all? It sounds like some kind of riddle, right? Well, it's actually a super fundamental concept, and today we're going to unravel it by getting crystal clear on distance, displacement, speed, and velocity. Okay, let's just dive right in with a little puzzle. Imagine you walk 2.5 kilometers to a market. Then you turn around and walk the same 2.5 kilometers all the way back home. So did you travel 5 kilometers or did you travel 0 kilometers? Well, the strange answer is you kind of did both. And by the end of this, you'll see exactly how that's even possible. To figure this out, we're not going to use complex equations. Not yet. We're just going to follow a really simple story. It's a scenario anyone can relate to, and it perfectly shows where the confusion comes from and, more importantly, how to clear it all up. So our story starts with a man walking from his home. His goal, a market that's 2.5 kilometers away, just down a perfectly straight road. A simple, straightforward trip from point A to point B. Now, this first part of the journey immediately introduces our first pair of really important ideas. Have you ever really thought about the difference between the actual path you walk versus the direct line from where you started to where you ended? Let's take a closer look. First up is distance. Now, this is the one we're all super familiar with, right? It's simply the total length of the path you actually cover. The best way to think about it is like the odometer in your car. It just keeps clicking up and up and up with every single foot you travel, no matter what direction you're going. And then we have its partner, displacement. Displacement is different. It couldn't care less about the scenic route you took. It only cares about one thing: the shortest straight line path from your starting point to your ending point. It's all about your change in position, as the crow flies. Now, here's where it gets really interesting with these two words, scalar and vector. For the trip to the market, the distance is 2.5 kilometers. That's what we call a scalar quantity. But the displacement is a vector. So, what's the difference? Well, a scalar just tells you how much. It's a number. But a vector tells you how much and in what direction. So it's not just 2.5 kilometers, it's 2.5 kilometers east. And believe me, that direction part is absolutely crucial. Okay, so we've got the where all sorted out. Now let's level up and add the element of how fast. We're going to bring time into the equation. Let's start a stopwatch for our guy's journey. So that walk to the market, it took him exactly 30 minutes, half an hour, a pretty good pace. And by adding time, we unlock our next two concepts. And just like before, they come as a pair. See the pattern? Speed is calculated using distance. It tells you how fast you're covering the actual ground. Velocity, on the other hand, is calculated using displacement. It tells you how quickly your position is changing from A to B. You could almost say speed is about how fast your legs are moving, while velocity is about how fast you're actually getting somewhere. Let's actually plug in the numbers and see how this works. His average speed is the total distance, 2.5 kilometers, divided by the time, which was half an hour. That gives us 5 kilometers per hour. Simple enough. Now for his average velocity. That's his displacement, 2.5 kilometers east, divided by that same half an hour. And that gives us 5 kilometers per hour east. So here's the key thing for now. On a simple one-way trip in a straight line, the numbers for speed and velocity can look exactly the same. But that is about to change in a big way. Because wait a second, the story isn't over. This is where our puzzle from the very beginning comes back. This is the twist that makes everything finally click. So he gets to the market, ready to shop, only to find out it's closed. So, frustrated, he just turns right around and walks straight back home along the exact same path. So here it is, the big question. For the entire journey, from his home to the market and all the way back home again, what are the final numbers for all four of our terms? What do you think? Take a second and really think about it. Okay, you ready? Let's break it down. This is the moment. This is where the true meaning of each of these four words becomes incredibly, undeniably clear. And boom, here it is. This table shows the whole point perfectly. Let's look. His total distance? That's easy. It's 2.5 kilometers there, plus 2.5 kilometers back, a total of 5 kilometers. His personal odometer says he walked 5K. But what about his displacement? Well, where did he start? At home. And where did he end? Right back at home. His final position is identical to his starting position, so his total displacement is 0, a big, fat 0.
And because of that, just look at the last two rows. His average speed is the total distance, 5 kilometers, divided by the total time, 1 hour. So 5 kilometers per hour. But his average velocity is his total displacement, 0, divided by the time. And of course, 0 divided by anything is just 0. His average velocity is 0 kilometers per hour. He's tired from walking 5 kilometers, but in the eyes of physics, his overall velocity was absolutely nothing.
So here's the absolute bottom line, the one thing you really need to remember. If you start and end at the exact same point, your displacement is always 0. It doesn't matter if you walked around the block or ran a full marathon. If you end up right back where you started, your displacement is 0, period. Okay, let's lock this in for good. What's the total path you traveled? That's your distance. What's the direct straight line change in your position from start to finish? That's your displacement. What's calculated from distance? That's your speed. And what's calculated from displacement? That's your velocity. And that right there is why you can run a marathon, cover over 42 kilometers. But if you cross that finish line right where you started, your displacement and your average velocity for the entire race are both 0. And that leaves us with one last thing to think about. A Formula One car finishes a 300-kilometer race right back where it began. As we now know, its average velocity for that whole race is 0 kilometers per hour. So, when the driver is flying down the track and glances at their dashboard, what is that speedometer actually showing them? Is it measuring their speed or their velocity? Think about it. Thanks for joining us for this one.